Hi, welcome to my video on functions. This is part one, and this video will define a function and find the domain and range. Also, in this series of videos, I will do function notation, and I will do composite functions and inverse functions. And if you wish, in my unit on Algebra 1, there's a unit on relations and functions that also goes over some of these definitions and how to find domain and range, etc. Domain is defined as the values of the independent variable. The values of the independent variable. And the range are the values of the dependent variable. So domain is independent, range is dependent. Let's look at some equations. Y equals x plus 3. The domain is the x and the range is the y. Your range, the y values depend on the x, so the y is a function of x. And in this one, A stands for area, S stands for sides, so the area in terms of the side, this is a square, which is s squared, so your domain is the values of the side of the square, and the range are the area A. And L equals 3w plus 40. The domain is the w, is the independent, and the length, L, so the length depends on the w. So if the w is, say 6, 3 6 18, the length would be 56. So this independent and dependent, domain and range. Normally when equations are solved, the one on the left is a function of the one on the right. So y is a function of x, the area is a function of s, L is a function of the w. And in this equation, we have the domain is the independent variable is theta as an angle, or as in degrees and radians. And we could say h is the height, or the range variable is the height. So the height of a Ferris wheel spinning around, or height on a graph, or whatever you wish, or dolphin swimming, sinusoidal functions. So the theta is the independent, and height is the dependent, domain and range. Just to give you a few examples. And let's look at the definition of a function. The set of all real numbers such that, notice we're talking about the set of real numbers, set of all real numbers such that each value of the domain, for each value of the domain, there is only one corresponding. There's only one corresponding value of the range. And some examples of that. Let's draw a little grid here. Let's say I have a line, linear. So for each value of x, when x is, notice what, for each x, there's only one y. For each value of x, there's only one y. When x is -1, y is this number, whatever it is. If x is 1, y is 1. If x is 2, y is 2. For each x, there's only one y. And another one we can draw is to look at it from this point of view. We could have it like this. There's many. For each value of x, there's only one y. For each value of x, there's only one y. And for each value of x, there's only one y. And that could be illustrated like this, as in a parabola. For each value of x, there's only one y. when x is 0, one value of y. For each value of x, there's only one value of y. So the value of the x's is only one value. And look at it from this point of view. Let's look at this one. Now, this is not a function. Why? Because when x, whatever x is right here, there's a y value on this vertical and on this vertical. So for each x, for when x is, whatever this value is, could be 1, then the y could have been -1 and 3 or 4. Makes no difference. But this is not a function, because for each x, there's, for when x is 1 or whatever, y has 2 values. So this is not a function. This is a function, this is a function, and this is a function, but this one's not a function. Another way to define that, if a relation is a function, it passes the vertical line test. Passes the vertical line test. And take this function that we just drew here, this one. If we draw the vertical line only passes through one point. So if we draw any vertical line through this relation to this right here, any vertical line, the vertical line intersects at one point. So it passes the vertical line test is another way they say it. Or if we take the one that's above right here, these dots, if we draw a vertical line, it only passes through one point. Draw this vertical line, it only passes through this point. Draw this vertical line through this point, it only passes through one point, and etc., etc. Or if you have a parabola, like this, and you draw a vertical line, it only goes through one point. So that's the vertical line test. When you draw a vertical line, it only passes through one point. And notice why the circle is not a function. Because when you draw a vertical line, it passes through 2 points. When you draw a vertical line, it passes through 2 points. And it only happens to have one vertical line. If a vertical line passes through 2 points, then the relation is not a function. Okay, state if each is a function and give the reason. So notice we have this one, and is it a function or not? Well, I can say for each, when x is 2, right here, y is 2. When x is 2, y is -1. So for each x, when x is 2, there's more than one y value, so this relation between these points is not a function. Or, another way to say it, if we draw a vertical line, the vertical line passes through the point 2, 2, and 2, -1, the vertical line passes through 2 points, so it's not a function. Y equals the absolute value of x. Well, if you do a little quick table of values for the absolute value of x, you got x and then y. If you let x be -1, the absolute value of -1 is 1. Let x be 0, the absolute value of 0 is 0. If you let x be 1, then the absolute value of 1 is 1. So if you draw that graph, so x is -1, y is 1. X is 0, y is 1. X is 1, y is 1. So a V shape is, an absolute value is a V shape, like this. So this V shape passes the vertical line test. Or for each x, there's only one y. And notice here we got x squared plus y squared equals 4. This is a circle whose center, x is 0, y is 0, and r squared is 4. So r is the square root of r squared plus minus the square root of 4. So r is plus minus 2, but the radius of the circle is 2. So we have a circle whose center is 0, 0 with a radius of 2. So center 0, 0, 2 to the right, 2 to the left, 2 up, 2 down. So just an approximation of a circle. So this is a quadratic, and notice that because it's it fails the vertical line test. In other words, when I let x be 0, so if I let x equal 0 in this equation, 0 squared plus y squared equals 4, then y squared equals 4, so that means the square root of y squared is plus minus the square root of 4, so y equals plus minus 2. So that means when x is 0, y is 2. When x is 0, y is negative 2. So when x is 0, y is 2. When x is 0, y is negative 2. So this is not a function. This circle is, or any circle, is not a function because it fails the vertical line test, or for each x there's more than one y. Okay, just explaining things to make sure you understand before we move on into the I say we're going to explain composite functions and inverse functions with more videos. Now, let's state the domain and range of each. So we have an equation. Notice this equation is 1 and 1 for the power. So that's a linear. So if you graph this equation, this is the slope is 1, which is right here, and the y-intercept is 1, which is right here. So this is y equals mx plus b. So we got a y-intercept of 1 cutting the y-axis right here, and your slope is 1, which is 1 over 1. You go up 1, right 1. You go up 1, right 1. Then what you have is, you have this line. So since this is a line, now, what values of x can fit into this equation? Well, the values of x, the domain are the values of x. X is the independent. The domain is the set of all real numbers. Any number, real number, can fit in hex here. And the range is the y, and the y's are reals. So as x goes to the right, y goes up. All the x's are in this graph, and all the y's are in this graph. And what about the f of x equals 1 over x minus 2? Well, x minus 2 cannot be 0. X cannot be 2, because if you have a 2, that creates the 1 over 2 minus 2. That's 1 over 0, and 1 over 0 is undefined. So your denominator, you let your denominator equal to 0 and solve it. You cannot have a 2. That means, if you think about it, if x can't be 2, so let's pretend that this is the x-axis, say this is 2. So if x can't be 2, that means we can't have x equals 2. So we can't have the point 2, 0, 2, 1, 2, 2, 2, negative 1, 2, negative 2. So we cannot, this is the y-axis, we cannot have this line. The vertical line is, we say this is an asymptote. So we cannot have 2. So what happens? As you let x get larger and larger and larger, so if you have x to be 3, if x is 3, you get 1 over 1, which is 1. If x is 4, then that's a half. If x is 5, then you have a 1/3. So as x gets larger and larger, going to infinity, the y goes to 0. So the reverse is also true here. Not the reverse, I shouldn't say that. What happens if you go to infinity? This goes to 0. What happens is as you get closer to 2? Well, as you get closer to 2, this goes up and up and up. The closer you get to 2, the higher the y will be. To give you an illustration, if I take, this is a 3, and that's a 2. If I take 2 and 1/2, so if I take x equals 2 and 1/2, that means x is equal to 5 over 2. So if you put 5 over 2 in here, you get 1 divided by 5 over 2 minus 2. It says 1 divided by, that's a half. So that becomes a 2. So as you get closer and closer to the 2 on this side, the y gets larger and larger. Again, you can put in a quarter or 2 1/4, and it'll be a 4. And on the other side, is if this is an asymptote, it tends towards the asymptote. And on this side, if you make x going to infinity, then the y value, so if x is 0, y is a negative a half, which is here. So it goes towards like this. And more discussion will come on this as I do as a unit on rational expressions, where you got asymptotes, vertical and horizontal. So not only are you have x is not 2 in this, but you notice that as x gets larger, y approaches 0. As x goes to negative infinity, y approaches 0. In other words, if you take x to be, say, 40, then this would be 1/38. If x is 100, this would be 1/98. So that fraction is getting smaller. So as x goes to negative infinity, then this, I say, negative 40 here. When x is negative 40, you get a negative 42. That gives you a smaller fraction. When x is a negative 100, you get a negative 102. So as x goes to infinity, this fraction is getting smaller and smaller, approaching 0. So that means that your domain here, your domain is x is not 2. And your range is your y, so your y is not 0. And think about it another way. I think of this way. Let's put a 0 on the end of this. So watch what happens. As x, if you can't put a 2 in for x because it makes the denominator 0, if you can't have a 2, you can't have a 0. That's another way I used to think about it. C, we have an exponential. So in this graph is that x can be any number you want. So if you do a table of values very quickly, let's look at the graph very quickly. If x is 0, that's a 1, so y is 4. If x is 1, so if x is 0, y is 4. If x is 1, 2 to the 1 is 2, we get a 5. So what happens here, your domain is x belongs, I can plug any value of x into this exponent here. So x belongs to the reals, but the range, no matter what I put in, if I put in a 0, I'll get 3 plus 1. If I put in a 1, I'll get 3 plus 2. So notice it's getting larger and larger and larger. So that means the range y is going to be greater than 3. So 3 is an asymptote, like that. And we have a growth curve, so it's doing this. So we've discussed the exponential functions before, but I just wanted to review them again. So x, you can use any value of x, so x is reals, and the range is y is greater than 3. If that was a negative, then the y values would be going down, less than negative 3. And D, p of x equals negative of x minus 1 all squared plus 4. I have, that's like y equals a outside of x minus h all squared plus k. So that's a parabola. So the vertex of this parabola is a 1, comma 4. So you have a 1. The vertex is x is 1 and y is 4. Let's stay right there. This parabola, because that's negative, it will go down. Now if x is 0, you'll get a 3. That means if x is 2, put 2 in here, you'll get a 3. So the parabola is doing this. Again, the vertex is 1, opposite of the bracket is 1. When x is 1, y is 0. The vertex is 1, 0, and because that's negative, it opens down. That means your domain for any parabola is x belongs to the reals. Any value of x can go into this equation. But your range is y is going to be less than or equal to 4. Remember, here you can have a 4. When x is 1, y is 4. So it starts at 4 and goes down because of that negative. So So your domain is real, the range is less than or equal to 4. Just reviewing some of the topics, functions that we did in the previous units before this right now. So this is just a review. State the domain and range of each. Again, x squared plus y squared is a circle. So that's a circle whose center is 0, 0, and whose radius is the square root of 9, which is 3. You can't say the radius is negative. So we have a circle whose center is 0, 0 with a radius of 3. So if your radius, the center is 0, 0, we go 3 to the right, 3 to the left, 3 up, 3 down. So we have these points, 1, 2, 3. Now here's the circle. Now your domain, because that's a 3 and a negative 3, and because that's a 3 and a negative 3, then your domain is your x values. So your domain is negative 3 less than or equal to x less than or equal to 3. Or we could also go square bracket negative 3 and 3 square bracket. Notice that the range is also just from, oh, that's a negative 3 there. The range is the same, negative 3 less than or equal to y less than, but domain is the x values, the range is the y values. And again, that can be named same as above, but again, the domain is the x's, the range is the y's. And what about this equation? The square root of 4 minus x squared. Well, underneath a root, the 4 minus x squared has got to be greater than, whatever's underneath root has to be it has to be greater than 0 and can also be equal to 0. Any number on a root has to be positive, because if it's not positive, it's an imaginary number. Example, the square root of negative 9. Square root of 9 is 3. The square root of a negative 1 is an I, so that's a 3i because it's imaginary. You can't do the square root of a negative number. And you can do it and call it imaginary, but it's not a real number. So we let 4 minus x squared be greater than 0. That means that if we switch this around, that means the negative x squared plus 4 is greater than 0. Multiply by negative 1, x squared minus 4 is less than 0. If you divide or multiply by a negative 1, the inequality greater than becomes less than. That means that x plus 2, x minus 2 is the factorization of this. That means x is negative 2 and 2. So what happens is that you can have that, but in relation to the number line of 2 and a negative 2, you can see that less than is in between. So you can have it equal to 2, you can have it equal to negative 2, and in between. Solution for this one is negative 2 is less than or equal to x is less than or equal to 2. Again, let's practice what we did before. We put a 3 in, we put a 0 in, we put a negative 3 in. If you put 3 in here for x, that gives you a 9. 4 minus 9 is negative 5. Nope. That'll give you a negative number underneath the root. Can't go. What about a 0? If there's a 0 in here, you get a 4. Square root of 4 is 2. That's okay. What about you put a negative 3 here? Negative 3 squared is 9. 4 minus 9 is negative 5. That gives you an imaginary number. So the only values of x that fit in here are negative 2 less than or equal to x less than or equal to 2. And if you think about that, the range, notice this is a positive. So all these x values are getting, no matter what I put in between here and here, that means that the y values are always going to be positive. So the y values are going to start as 0. So that's the domain. So the range is going to be y is greater than or equal to 0. Oop, I put a 1 in. The y values are going to start at 0 and go up. Let's look at another way. What's this trick? If the h of x is equal to y, so if I make the h of x a y, that means I can square both sides. So y squared is equal to the root of 4 minus x squared all squared. So y being squared is y squared. And the root of 4 minus x squared all squared is 4 minus x squared. And that means that x squared plus y squared equals 4. So we have a circle whose center is 0, 0 with a radius of 2. But notice it comes from a circle. Let's put the circle right here. 0, 0 with a radius of 2. Like this. Pretend that's 2. But we're not allowed. This is the y value's got to be greater than 0. So if I work backwards and I get a circle, this is not quite a circle. This is, the x's go from a negative 2 to a 2, but the y's are positive. So what I have here, so the y's, going back, I said y is greater than 0, but I gotta be careful, because that's a 0 here, and if this is coming from this circle, then this is a 2 here. So it looks like the y's could be positive and go on to 0, but it's not. The y values are from 0 less than or equal to y less than or equal to 2. So this is a tricky one. Going backwards and doing what I'm doing here will give you a circle, but this is the y values which are a plus. So it's a plus in this circle, so it's this graph right here. So again, that's tricky. Domain is okay to get between 2 and negative 2 and equal to, but the range, you have to go back and do this trick that I do here. Where is this coming from? This is coming from the upper half of a circle. It's not the lower half. It's the upper half because of that plus. So that's a little bit different. And that will, I'll bring that up again, or I will bring it up in a unit that I'm going to do on semicircles and circles and things like that. If, to end this section off, the p of x equals 1 over the root of x plus 6 minus 2. Now, that means we have a double wet. We got to be careful here. We have that x plus 6 is a root. So underneath the root, it has to be greater than 0. We cannot have it equal to 0 because it's a, if we say greater than or equal to 0, that means we can have x is negative 6. And negative 6 going in here gives me a 0. And 1 over 0 is undefined. So we can't have it great underneath the root. We can say greater than or equal to 0. But because the root is in a denominator, we had to be careful and say the x plus 6 is just greater than 0, but not equal to 0. So that means these values of x got to be greater than negative 6. And think about it. If you just do a quick little table of values, just to show you, if x is not negative 6, so if x is greater than negative 6, let's say negative 5, and negative 4, and negative 3. See what happens. If x is negative 5, that's a 1. Square root of 1 is 1. So 1 over 1 gives you 1 minus 2. You're okay. What about you put a negative 4 here? You get the square root of 2. That's okay. What about you put a 3 here? You get the square root of, put a negative 3 here, sorry. Negative 3 here will give you a positive 3. Square root of positive 3 is okay. If you put a negative 2 here, you get a 4. Square root of 4 is 2. That's okay. So you can see that the x values are going greater than negative 6. If you took a negative 10, put negative 10 in place of x, what would happen? You wouldn't be able to use a negative 10 because the negative 10 plus 6 is a negative 4, and the square root of a negative 4 is an imaginary number. Now, that's the domain. The domain are the values of x that are greater than negative 6, but not equal to. So what happens? As the values of x gets larger and larger and larger, this number gets larger. So the 1 over the root of x plus 6, as x gets larger and larger and larger, this fraction will get smaller and smaller and smaller and go to 0. Think about it. If this is 1 over 1, but that gives you 1. If this is 1 over 2, that's a half. If the fraction is 1 over 10, 1/10. So whatever number I put in, if the denominator is getting larger and larger, that means this fraction is approaching 0. That means that this expression, 1 over root x plus 6 minus 2. So this is approaching, as x gets larger, going to infinity, then this fraction goes to 0. That means this expression, if this goes to 0, so this expression goes to negative 2. So as your denominator gets larger, this fraction gets smaller and smaller, approaching 0. So that means the y is approaching negative 2. So your domain is x is greater than negative 6, and your range is your y is, and that's a plus. So it's approaching the negative 2, and it's going greater. It goes up. So hopefully that helps. Again, I'm just looking at some explanations. And if I had a graph, sometimes when you have a graphing calculator, I can plug this in a graphing calculator and see what happens. So allow me to use my graphing calculator to explain this a little bit more. So let's look at the graph, and I got 1 division, and I got the square root of x plus 6. That's the square root, and then I'm going to subtract 2. Let's see what we get. There we go. So, oops, sorry, I lifted that up. You can see that this is the negative 2 going along here as an asymptote, so it's greater. It's greater because I know that's a positive, and it's going to get larger and larger and larger. If that was a negative, this would be going down from a negative 2. Because if this is negative, then you would get a negative number, add on negative 2. So it's negative 2 plus a negative, it'll give you a negative 3 and a negative 4. So whatever this is negative, negative 2 plus is negative, it'll go down, down, down. And just to illustrate that, if I can, I won't be able to get the negative in without changing it. I'll go to the next line and do negative 1. We'll do a division, and we'll do a square root, and I'll do the x plus 6 again in bracket, and then I'll do the minus 2. So it's the same graph, and what I'm going to do is I'm going to go over, I'm going to just undo that one, and let's see if it goes down. There it is. So there's the asymptote going along at, right along here at y is negative 2. But you can't have a negative 2. So if that's negative, it will go down. So your domain, your range would be y is less than negative 2. But you'll see more of that coming up. I just introduced a few now because we're doing different topics at different times, then you'll see me go over some of these topics again later on in different units. Oh, bring that back. And again, this brings us to the end of the review on domain and range and what a function is. And if you like my video, click the like button, click the subscribe button. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.